Hi everyone! Have you ever wondered why cyclones always form in the tropics? And why in the northern hemisphere cyclones typically move in a northwest direction? Well, this is because of a phenomenon known as the Coriolis effect, which affects moving objects in a rotating reference frame, like cyclones moving on the face of the planet. And it was first explained by Caspar Gustav Coriolis. Before we go into the Coriolis force, let's think a little bit about reference frames and forces. Remember that a reference frame is just a convenient coordinate system to solve our problem in. Like this, it can be fixed, inertial, or moving, non-inertial. Let's also define a convention where we say that real forces are positive and imaginary forces are negative. What do we mean by that? Think about a fixed reference frame, you standing on the ground and your friend moving by in a car. As she accelerates, the only force in this coordinate system is on the car, positive, pushing it forward. Now think about a moving reference frame in which you are sitting inside the car. As you accelerate, the car is getting pushed forward, a real force, but your inertia is pushing you back in relation to the car's reference frame, like so. This is a fake force. Similarly, when you come to a corner, the friction of your tires is pulling the car radially inward in a real centripetal force. However, because you are always pointing in the direction tangential to your driving direction, the net effect is to push you out of the corner in a fictitious centrifugal force. These kinds of forces will mostly do in most classical mechanics problems, but when the reference frame itself is rotating like this, you can have a third fictitious force that becomes important, the Coriolis force. Okay, at this point you can ask me, why does rotation even matter, Vamsi? Well, it matters if you want to do cool stuff like launch a satellite into orbit, track cyclones on the planet, clean up our oceans, or run an airline company. Okay, I'm a bit woozy with all that rotation, so I'm going to allow Angry Birds to explain to you what Coriolis is. Let's say we are standing in space right above the North Pole, and on diametrically opposite points on the equator there is your friend with a catapult aiming an angry bird towards a pig on the other side. The bird is fired, it has a poleward velocity towards the pig, and because the earth is rotating counterclockwise with respect to you, it has a right side velocity. Now over time the bird keeps moving in a straight line given by the relative magnitudes of these two velocities and completely misses the pig. Okay, let's repeat this experiment, but now standing next to the pig. Everything is as before. Your friend fires the bird, it moves in a straight line towards the pig. Now after a while, let's say the earth rotates a little bit. Does it continue to move in a straight line? Oh, this straight line is different from the previous straight line. So what must have happened is that the bird must have actually curved a little to its right or a little to our left relative to our rotating reference frame. We see this again and again throughout its trajectory. Now, this apparent curving is because of the Coriolis force, a fictitious force that affects objects moving in this rotating reference frame. And as you saw in that montage, the curvature is very small close to the equator and maximal at the poles. So to summarize, in a counterclockwise rotating reference frame, any object that is moving is going to experience a centrifugal force that wants to push it out from the center of the reference frame, and an apparent force that is going to deflect it or curve it to its right. This is the Coriolis force, and the Coriolis force is minimal at the equator and maximal at the poles. Okay, what has all this to do with cyclones? To form cyclones you need two things. One, you need the Coriolis force, and two, you need warm air. Given what you know about the Coriolis force now, can you tell me why cyclones will only form in the tropics and not at higher latitudes or at the equator? Yep, you guessed it. At the equator there is no Coriolis force, and in the tropics you have the most warm air because of the highest heating by the sun. Now, given all you know about Coriolis and these prevailing wind patterns on the earth, can you explain why cyclones in the northern hemisphere always move northwest? Well, that's it about the Coriolis force. Please look at the supplemental material to solve some more conceptual math problems and get some interesting insights into Coriolis force. Thank you.